welcome back to Josh Does Math. In this video, we're going to be looking at the continuity of the function 1 over the root of x. So I know that a function is continuous if three criteria are met. If the function value exists for every x, if the limit value exists for every x, and if the function value is equal to the limit value. So if any one of those three criteria are not met, then the function is discontinuous at that point. So the first and easiest criteria that I'm going to look for is seeing if the function has a value for every x. In other words, does this give me a real number for all values of x? Well, let's think about when it would not give me a real number. It's not going to give me a real number if the denominator is equal to 0. So if I solve this for x when the denominator is equal to 0, that will give me some x where it's discontinuous because I'll have division by 0. When else would this function not be defined? When else would it not give me a value? Well, maybe if I put a negative under the square root, because then that would give me an imaginary number, not a real number. So I'll take whatever's under the root and say if that's less than 0, then I'm going to have a discontinuity for those x values. So for this and this, those are whenever I have discontinuities. So let's solve each of these and find the values for x that will give me discontinuities. So x is equal to, root of x is equal to 0, and x is less than 0. Well, already this one is simplified as much as it can be. Root of x is equal to 0. Okay, I'll square each side. X is equal to 0. So if x is equal to 0, or if it's less than 0, I'm going to have I'm not going to have a value for the function. In other words, it will be a discontinuity on the function. So I'll just combine these two together into one statement and say if x is less than or equal to 0. That is when I don't have a function value, so therefore the function cannot be continuous over there. So these are the points of discontinuity for the 1 over root of x function. Thanks for watching.